Next, we will discuss the classical approach, which is a method of finding the probability of an event defined for an experiment with equally likely simple outcomes. Again, the question that we will try to answer is about how to find the probability of an event. And we already understand that for every event, there is an experiment for which there exists the sample space, which consists of all possible simple outcomes. In this section, we consider only those experiments for which all simple outcomes are equally likely. And in such case, to find the probability, we use the following formula, in which E is an event in question, F is the number of ways that event E may occur, or the size of the set that defines the event, and N is the total number of outcomes, which is the same as the size of the sample space. So to find the probability of an event, we can just count the number of outcomes in the set definition of the event and divide it by the size of the sample space. Consider the following example. Let's find the probabilities of the list of events when a fair coin is flipped 3 times. To use the formula, we first need to identify the experiment and its sample space. The experiment is tossing a coin 3 times, which has a well-known sample space of size 8. For every event, we will find the set description of an event, that is, list all simple outcomes that define it, then figure out the size of it and divide it by 8, which is the size of the sample space. For example, for event 8, there are only 3 outcomes: tails, heads, 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 tail, heads, and heads, heads, tails. Therefore, the probability of event A is 3/8. Similarly, for event B, there is only one outcome: heads, heads, heads. Therefore, the probability of event B is 1/8. Similarly, for event C, there are 4 outcomes. Therefore, the probability of event C is 4/8. Finally, for event D, there are 7 outcomes. Therefore, the probability of event D is 7/8. As you can see by the definition of the method, it is impossible to get a number less than 0 or greater than 1. This result validates our choice of denoting the probability of impossible event as 0 and probabilities of certain events as 1. We discussed the classical approach, which allows to find the probability of an event defined for an experiment with equally likely simple outcomes.